A conductor wire having high resistance is called resistor. Now I am talking about parallel combination of resistor. For this, look at this, these three resistors are taken and I am going to connect them parallelly this way. This is parallel combination of these three resistors. We can define this parallel combination in this way. When resistors are connected in such a way that one end of each of them is connected to a common point and another end of each of them is connected to another common point, and due to this type of connection each of them gets same voltage across this first resistor. Let's say its resistance is R1, the resistance of second is R2 and resistance of third is R3, but they are getting same voltage V. Now thirdly, what can I say? When resistor, one end of each resistor is connected to a common point, another end of each of them is connected to another common point, due to which all of them gets same voltage, then the combination is called parallel combination of resistor. Now I want to talk about the characteristic of parallel combination of resistor. Just now I told you that in this combination each of the resistor gets same voltage. Each resistor gets same voltage. This is one of the characteristics. Second point, when current is supplied from one of the end, let's say current is I. Now after this point, certainly the current divides among these three branches. Maybe here I1 we can represent by symbol I1, I2, I3. This current divides among three different branches. That's why in this combination current divides among the resistors and total current I will be equal to the sum of the current flowing through each resistor. If there are other resistors also, the same current divides among all the resistors. I mean to say current divides here, but in series combination they will divide, but in parallel combination current divides. This is one of the great characteristics of parallel combination of resistor, where the sum of the current in each of the branch is equal to total current. Now let's talk about third point. Now before this I want to tell you something other than this. We know that V equal to IR according to Ohm's law, potential difference equal to current into resistance. And in this combination, as I told you just now, I equal to I1 plus I2 plus I3, and if there are other branches also, so on. Now if V equal to IR, then I want to make one equation here. If V equal to IR, V equal to IR, then I will be equal to V by R. And in the same way, look at this, if total current is I, total voltage is V, then according to Ohm's law, V equal to IR. If it is so, then current is equal to V by R. Now I want to talk about each of the branch. For first branch, same V equal to IR will be, V remains same because voltage is not different, V is same, but I is not I here, it is I1 only. In first branch current is I1, and resistance is not total resistance. In first branch resistance is R1. That's why V equal to I1 R1 for first branch, and the same can be written as I1 equal to V by R1. Now for second branch, let's talk about second branch. We have same V because voltage remains same for each of them in this combination. But current in second branch is I2 and resistance of the second resistor is R2. Therefore, I2 equal to V by R2. Now for third branch, V equal to IR becomes, V remains same, current is I3, resistance is R3. So I3 equal to V by R3. Now I want to put this value here. In place of I want to put V by R. I is V by R. In the same way, I1 equal to V by R1 and I2 equal to V by R2 and I3 equal to V by R3, and if they are other also we can write. Now if B is taken as common in right hand side, then we'll have 1 by R1 plus 1 by R2 plus 1 by R3 and so on. V cancel. Therefore 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. What is the meaning? What is the conclusion? 1 by R means reciprocal of the total resistance, and this is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. It means we can conclude that reciprocal of the total resistance is equal to sum of the reciprocal of the individual resistance. These are the basic characteristics of parallel combination of resistor. First, I told you about the definition. How can we define? When one end of each resistor is connected to a common point, another end of each of them is connected to another common point, due to which each of them gets same voltage, then the combination is called parallel combination of resistor. Now next, in this combination, voltage does not divide among the resistor. Each of them gets full supplied voltage. And another characteristic of this combination is current divides among the resistor and total current is equal to sum of the current flowing through each resistor. And after this simple derivation, what can we conclude? In this combination, the reciprocal of the total resistance, which is denoted by 1 by R, the reciprocal of the total resistance is equal to sum of the reciprocal of the individual resistance. This way we can understand a little more about the parallel combination of resistors.